So today's notes, we are going to be looking at the vertex form of a quadratic function. So the vertex form of a quadratic function is this. So y equals ax minus h squared plus k. We've already looked at one form of a quadratic function, and it is our expanded form. So it looks like this, ax squared plus bx plus c. Vertex form is another way of writing a quadratic. It just looks a little different, right? And it tells us similar things. Say over here. So a x minus h squared plus k. We already know what a does. So when I make a larger numbers, it gets narrower. When I make it a number in between 1 and 0, like a smaller number, it gets wider than usual. So normal width is 1. Okay, when I have negative numbers in, it opens down. Positive numbers open up. So we already know what a does. All right, so with h, let's see what it does when we move it. So as you can see, nothing is changing with my width. The only thing that is happening is I'm moving my vertex along the x-axis. Okay, when I change k, I move my vertex along the y-axis. So if I take h of 2 and k of 3, I should have the vertex of 2, 3. And if I take a look here, so 2 in my x, 3 in my y, here's my vertex 2, 3. So vertex form tells us the location of our vertex, which is why it's called vertex form of parabola. We know that h and k is our vertex coordinate, and a is the same. So a is the same for standard form as it is for vertex form. So positive opens up, negative opens down. If it's 1, it's a normal width. If it's larger than 1, it's going to be narrow. If it's smaller than 1, like a fraction, like 0.5, it is going to be wider. Right. So let's do this first example here. So we're going to complete this table. So for the function y equals x minus 2 squared, what is h, k, the direction of opening, the vertex, and the axis of symmetry. Right. So a is our number out in front, and there is nothing. What? So is it 0? Of course it's not. We're lazy mathematicians. We don't write ones. Okay, we have one of these things. So a is a positive 1. So since a is positive 1, that tells me its direction of opening. It's going to open up, right? And from my HK values, I can find out where my vertex is and my axis of symmetry once I know my vertex. So H is right here. So you're going to have to watch out. Okay, so the formula is negative H, right? So if I have a negative in here, that's part of my formula. Okay, so here we have H is going to be 2, and there is no K value, so it is 0. So my vertex will be at 2, 0, and my axis of symmetry, my equation is always x equals, and then just whatever my h value is, so 2. Okay, now let's check that out using a graphing calculator or Desmos app. All right, so here we have the function x minus 2 squared. So if I take a look here, it's not negative 2. Okay, so when I have this function in here, this minus 2 here, my graph, you'll see my vertex is at 2, 0, not negative 2, 0. Okay, so you have to remember um, when you're doing this that you need to take the opposite sign for h. Okay, so when we put a number in there, so let's try out this next one, this next example, and you'll see what I mean. Okay, so if a is negative 1, let's put a of negative 1 in there. Okay, and then x. So it should be x minus h. So x minus, and then my h is negative 4, okay, squared. And then k is minus 3. So when I have put a negative number into my formula for this x minus part, so if I have x minus negative 4, minus a negative turns into a plus. Okay, so this will look like not x minus negative 4, it'll look like x plus 4. Right? And since we're lazy mathematicians, we don't write ones, so this would be negative. And then x plus 4, all in brackets squared, minus 3. Okay, so negative h values look like pluses, positive h values will look like a negative. When I put a positive 2 into this formula, it looks negative because there's a negative sign in the formula. Okay, so just remember that. So when I put a positive in, it looks negative. When I put a negative in, it looks positive. So take the opposite sign. Okay, so now that that's underway. So -1 is my A value, so it will open down. My vertex is going to be at whatever HK is. So my vertex is -4, -3, and my axis of symmetry is x equals whatever my H value is, so -4. Okay, next one. Same thing. So invisible 1 there. So I open up and my vertex. So for this guy, if I wasn't sure still, I could graph it. So let's graph x minus 1 squared plus 3, and let's see what it looks like. So that would be this guy here. So x minus 1 squared plus 3. So here I have my vertex at 1, 3. So +1, 3. Even though it looks like it should be -1, for that one we have to take the opposite sign. So +1, 3 is where my vertex is. Oh, geez, what just happened? Okay, so +1 and 3. Okay, so my vertex will be at 1 and 3. 1, 3. So my line of symmetry will be at x equals 1. Last example here. So A is -2. So since it is a negative, it is opening down. And it will also be narrower, but I'm not asking about width. All right, so then H right here. So since it's +3, this is like minus a -3. Okay, so our H value is -3. So change that sign for that one. And -1. And if I was unsure, I could, of course, double check. And here's my formula. So -2x plus 3 squared minus 1. And I can see that my vertex is at 1, 2, -3 and -1. So -3, -1 for my vertex. So yes, I am correct. So -3, -1. And so x equals -3 for the equation for my axis of symmetry. Right. Now, for this quadratic function, we are going to list the following properties, just like we did up here, and then we're going to take those properties and we're going to use them to sketch. Okay, so first it opens right here. So this is a positive value, so it will open up. Its width, since it's a 2, is going to be a little narrower. Okay, the vertex is going to be at +2, -3. Okay, the equation of my axis of symmetry is going to be at x equals 2. And my number of x-intercepts. So let's do a quick graph before I do this. So it opens up. The vertex is at 2, -3. So 2, -3 is going to be here. It's going to be opening up. So I'm going to have 1, 2 x-intercepts. Notice I'm looking for number of x-intercepts, not what the x-intercepts are. So I have 2 x-intercepts. Okay, next, I can't tell what my y-intercept is from vertex form. So I have to turn it into standard form. And how I do that is by expanding. So we are going to expand this function. So we have 2 and then x minus 2 squared minus 3. So we're going to expand this x minus 2 squared. So x minus 2 squared just means that I have x minus 2 multiplied by itself 2 times. So x minus 2 times x minus 2. And then to expand this, we can FOIL it. So first, outside, inside, last. So the first terms are x times x. So I get x squared. The outside terms are, so this x and this -2, so the terms on the outside. So x times -2 is -2x. Then the inside terms is this -2x again, so -2 times x, so the terms on the inside. So the last terms are -2 times -2, so last terms of each is +4. Okay. So we have 2 times this minus 3, just carrying down those other things there. Okay, so this turns into that. Oops. And let's just make this look a little nicer. Add our like terms, so we get x squared, -2x, and another -2x is -4x plus 4, and then minus 3. Okay, next we need to finish expanding these brackets by multiplying this 2 inside. So 2 times x squared is 2x squared. 2 times negative 4x is negative 8x. And then 2 times positive 4 is positive 8. And then just having our carrying down our negative 3 at the end. Okay, so now we have 2x squared minus 8x plus 8 minus 3. So positive 8 minus 3, we have like terms here. So 8 minus 3 is a positive 5. So we get y equals 2x squared minus 8x plus 5 is this equation into standard form. If I wanted to check, I could go into my graphing calculator, put this one in along with my original one and see if I get the same parabola. So here's our graphing calculator. So 2x minus 2 squared minus 3 is this graph right here. And then this one, our expanded form should also show up. And oh, it is, as you can see, the same one. So that one's there. This one's also there. They are the same. So we should have expanded correctly. Should be good. All right. So our y-intercept, we can clearly see from our standard form, and our y-intercept is right here at positive 5. So our y-intercept is at 5. Next, we are going to sketch this function. Okay, so in order to sketch it, we are going to take these things that we know about it and put them down. All right, so we have our vertex at 2, negative 3, so 1, 2, and then negative 3, so 1, 2, 3 down here. Okay, and it's opening up. Our axis of symmetry is obviously right here, so x equals 2. So we are going to draw that. Hopefully your line is a bit nicer than mine. And we know the y-intercept is at 5, because my y-intercept is all the way up here at 1, 2, 3, 4, 5. Right there. And I know from my axis of symmetry that if I have a point here, I'm going to have a point exactly the same distance away at the same height. So right there. And I can tell that this is going to be a bit narrower than usual, which is what I'm expecting. And I am getting 2x-intercepts. Okay, so, and try to draw yours not so hideous, please. Oh, there we go. And we have already checked it using our graphing calculator right here. So down here at 2, negative 3 is where our axis of symmetry is. We have our y-intercept up here at 5. And if I did want to figure out what my x-intercepts are, I could check them by graphing. Next lesson, we are going to learn how to find those, but not this day. All right, so here's our sketch, and we are done.